Hello, I'm Jakub. I'm from Arcant, and today I'm going to present you a project that I worked on with four of my colleagues and developer colleagues. I'm also a developer, and in this session, we're going to talk about assembly manuals on top of the APS viewer. If you want to know more about Arcant, then I recommend you to visit this link below here. And this talk is going to be focused on a manufacturing-related field. Assembly manuals could also apply to construction, but if you are coming from manufacturing, you might be interested in this pretty much. So in this talk, we're going to be focusing, as mentioned, I'm a developer and my colleagues are too, more on the development gotchas and the development side of things, and kind of the ways to obtain the data for the what we call Autodesk Viewer, that is the APS viewer. And in the end, there is essentially a bunch of acronyms used in these slides. So in the end, you will find out, for instance, what does LOC mean. A little bit of an introduction as to what assembly manuals is about. It is a web application, so in this slide on this picture, you can see a web page of the manual. In the center here, you can see the APS viewer. On the right side, you can see a design BOM. On the left side, you can see a manufacturing BOM, and below that, you can see steps with just one step. But this panel can get quite involved. So there could be a lot of data. And below the viewer, you can see the area for attachments and also an area for step description. So as you notice, this page is quite data heavy. It's not just about making sure the viewer loads up quickly, but also what we call metadata surrounding it around, and it can get quite interactive. I'm gonna demo it a bit later on in this presentation. The hard criteria of this project is that it should work on premise. That means on a customer server inside their internal network. But of course, the viewer assets need to be hosted on Autodesk servers. So the application needs to have reached to the internet. And in manufacturing companies, sometimes it happens that the internet is down. So a caching worker should be ready to kind of not interrupt the service and to kind of help the service keep going. The data for this application needs to be prepared because it's coming from Inventor, and for that reason we use, and maybe you're familiar with these windows, we use something called job processor of Autodesk Vault. Here is a high-level overview of the architecture of the software, I guess a bit too high, but essentially here the V stands for Vault, I for Inventor, and on the right side here you can see assembly manuals application, which has its own components. In here, what we mean by Inventor really in our case is that it's the InventorServer where we process the assembly, so this isn't really meant to be a full Inventor, but I of course assume that a full Inventor can be used later on. It's essentially just a one piece with Vault where we have developed a Vault extension, and part of that Vault extension is something that we call Inventor Library, and the code of the Inventor library is executed using the InventorServer. And so in Vault, it is where it all starts. And so we have an assembly there, Inventor assembly, IIM, and that's passed for pre-processing or for processing for translation to Inventor. And Inventor either translates it directly to SVF or DWF as an intermediary. And the second part of the data that it outputs is something that we call BUF, which is essentially the metadata. And one Vault has that it sort of uploads the SVF, the 3D representation of the data, and the BUF, the metadata representation, to the assembly manuals application itself. It could, of course, be any other application, so that's just to give you an idea of what we're doing, and maybe you can draw an inspiration from that. Once the web application has this data, it stores it into its own file store, and it, of course, stores its own data, manual data, and other pieces of data into its own database. And there's, of course, as I said, this is too high level, an application server in there. So the data coming from Inventor can get quite complex, and I'm just gonna explain two terms that we use through the presentation here. Here is a design bomb from Inventor, and essentially what you can see here is that some components appear more than once here. That means they occur more than once here, as you can notice by the name in front of the colon. And behind that colon, there is the number of the occurrence. So this component, for example, is here twice. And components can also be called documents. And in the Inventor API, there are called components, documents. And so on the right-hand side here, I am showing a little bit of code of usage of two bulk operations, or what I call bulk operations, that can be very important in case you want to kind of speed the processing of the data quite a bit. So in our project, we used this essentially a method, even though here it looks like a property, called all reference documents. And this call kind of gives you a list of reference components, or in other words, documents, in a single operation. So we use this when we remove all luminescence, which is something I'm going to talk about on subsequent slides. Down below here, we have something called all reference occurrences. We decided not to use this call for our purpose, because we kind of need to the nested kind of data structure that the Inventor gives us to kind of be able to go through it in a tree-like data. And this call outputs a list of data, so that means it would need to be further pre-processed. But this is something you should consider if you want to make the data processing faster. Let's talk about what we have in Inventor. For the purpose of this presentation, we have two assemblies. These are pictures from Inventor. And on the left, we have CNC machine, and on the right, we have a packing machine. And for now here, just notice the yellow parts here. The CNC machine size is 350 documents, and it has 700 or about 760 occurrences. The packing machine has about 850 documents, and it has about 7,600 occurrences, which makes it about 10 times bigger than the CNC machine. So what is the SVF? The SVF is the 3D file format for the APS viewer, and it's developed by Autodesk. And in this presentation, what I really mean by SVF is the SVF version 1, since we have this criteria to kind of have the application work on premise. I have digged into the SVF file format version 1 in order to retrieve metadata outside of the viewer API, and I've managed to have some successes with that, but that's a topic on its own. We're gonna stay a bit at a higher level and just see how we can even get the SVF version 1. On this slide, I am essentially showing you or explaining 4 ways to obtain SVF, but there are really just, as far as we know, 2 translators that you can use on-premise locally. And the first one is Vault Translator. Essentially, it takes in the DWF 3D file format as an intermediary, and it's pretty much a CLI tool, as you can see on this picture here. It's DWF to SVF exe, and once you try to invoke it in the command line, there is not much of a help to it. And there is something that is optional called index.json, and we think that's some sort of a configuration file where you can put some kind of configuration, but we didn't really figure out how to use it, so we don't include it when calling this tool. And maybe that's why we have a problem with part colors not being properly override, in a sense of that if you have a color defined, let's say on a subassembly level, then that color isn't propagated down to its parts using this translator and EMT config essentially. As for the Inventor translator, we have option there too called skip remove and luminescence. That is if we want to remove luminescence or not. I'm going to talk about luminescence later. And down here you can see a little bit of a look into Inventor or when to find this translator, even though it's enabled by default. So on this slide, we have in the center the picture from Inventor, and on the sides we have pictures of those SVF generated by all of those 4 ways. On the left, we have the pictures coming from the Vault translator, and on the right, we have pictures coming from the Inventor translator. And as you can notice, none of it really matches the Inventor picture. Right here, the most noticeable is this white cover, and it has a flame sticker, and the flame sticker is kind of where it's the only case where it's present. On all of the other 3 cases, the flame sticker is gone. And also down here, you can see that the cover is kind of in a wrong color again, even though this picture is for when the skipping of override colors is not applied. So that means when colors of parts are overridden. So there might be some sort of a mistake in the algorithm itself. But at least for now, the algorithm is fast, so it's not really slowing down the overall process before the SVF is exported. On the right side here, you may notice that there are some very bright colored parts here, and those are the parts that you get when you have luminescence or something called luminescence defined in Inventor. And on the bottom right picture here, those parts have the correct color. So this is where the removal of luminescence is applied. Here on this slide, I'm showing times to generate the SVF in all of those 4 ways. And by the first column, I really mean if it's true here, then the Vault translator is used. And if it's false, then the Inventor translator is used. And then options that apply to those. So the winner time-wise here is the Inventor translator. And but really, as you have seen on the pictures, what you might choose is the time with the highest value here, so the worst time. So that's because it's kind of necessary from this assembly to remove luminescence, and the colors there were kind of closest to the representation or colors in Inventor. As for the packet machine, again, we have the inventor picture here in the center, and on the left side we have results or how does the SVF file look like after using the Vault translation, and what do the SVF look like after using the Inventor translator. And as I've mentioned, the yellow parts are present in the Inventor assembly, but in those SVF using both of those translators, they're essentially, as you see, they're gone. And I'm not sure why that is, but here I can only recommend if you want to attempt something like we did here to always test with your data. For the packet machine, the time to generate the SVF file, as you can see here, again, the left column means if it's true, the Vault translator is used. If it's false, then the Inventor translator is used. And the lowest time here goes for the Vault translator without overriding the part colors. But again, even in this case, the highest time here, and there were some luminescent parts in there too. They were very small, but this option is what you might choose. So always check with the provider of the input data if they use this luminescence feature. Here is a little bit of a documentation on how to find the luminescence or where it is defined in Inventor. So it's on the appearance. After you select the part, you check the particular appearance, and down here is an area called self-illumination. And once the luminance value here is higher than 0, then you get this effect in the resulting SVF translated using the Inventor translator in a bright, very bright color. On this slide here, I have a picture from Inventor Program and Help. And essentially, this doesn't really mention what we use there, which is InventorServer. So I have this on the slide right here on the right side. But it mentions important thing. And so essentially, if you want to make sure that the process before the translation, the processing time, those calls to API of an inventor that you need to do are done quickly, then you might want to consider just making it an add-in and run it in a full inventor, because as according to this picture, when you have in Inventor some sort of iLogic code, or when you have code for your add-in and use an add-in in Inventor, in these two cases, the code is executed in the process of Inventor. So there is a huge advantage in processing time. The processing time is much lower. But in case of InventorServer, if you do API calls from there, it goes over COM interface. And so you have to choose carefully how many times or how often do you call into Inventor API in your code. And you might want to do the code rather differently than you're used to when, say, doing an Inventor add-in. So even though InventorServer is part of the job processor and doesn't require you to have a license, the process itself doesn't really run inside the Inventor. So, and same thing, if you use full Inventor, you can open it up and essentially instantiate it from the job processor. And it also runs out of process, but it does require Inventor license, but it's not any slower because you can tell it to run in headless mode and not load the graphics when opening up the assembly. And so it's not any slower than the InventorServer. The advantage of it is, of course, it's a more full feature than the InventorServer API, which you can find is sometimes limited compared to full Inventor. So here I kind of speculate if it's a good idea to, in case you think that the InventorServer startup and shutdown on every job is kind of slowing things down, if it's good to just use the full Inventor, but of course you need to have a license if you want to use the full Inventor, and you kind of need to manage that process or when to restart it yourself. So I think this is more like complications. But again, if you have the option to use full Inventor, maybe you could move all of your code into an add-in and just execute command that you can have defined internally from the job processor itself. So maybe that's an option if you want to go much faster. In our case, the time I have shown you are for InventorServer. All right, next I'm going to talk about annotations, essentially. GD&T, another acronym, stands for geometric dimensions and tolerances. And so that's essentially annotations. And here we run into a problem with annotations. On the left picture here, you can see an SVF with a dimension coming from the Vault translator. And on the right, you can see a picture from the Inventor translator of the same thing. And as you can see on the right, the dimension is correct. It has these lines, and on the left, in case of Vault translator, it's missing these lines, even though down here we define that in the viewer, the hide line options is set to false. So that's something you need to be aware of in case you need annotations in your SVF model. Here is again a little bit of a documentation on how to set this up in Inventor in case you need all of the annotations from your assembly. Let's say some annotations are defined in sub-assemblies or deeply nested within the assembly, then you need to check this box called component 3D annotations. And then that will mean all of the annotations will export to SVF. During the development, we run into something that I call green annotations. I wasn't able to reproduce this issue, so on this picture here, what you see is a gray annotation for the purpose of this presentation. But if you run into that, I'm pretty sure it's due to usage of the full Inventor, and if you use the Inventor translator. But if you run the translation in the context of the job processor, you can use InventorServer to do the translation. So the idea is to, if you need full Inventor, you would first process your data using full Inventor, and then you close the assembly while saving it and reopen it using InventorServer, and then you get the correct grayish color of dimensions in your SVF. But of course, this adds to the overall processing time. So it depends if you need annotations and also full Inventor. All right, let's mention some more of the configuration options of the Vault extension. I've talked about some of these that you can see here on this slide. So we use JSON for the configuration. And some say that JSON isn't very great fit for configuration as you cannot have comments, but the .NET parser has no problem with comments. So we just kind of use JSON for configuration here. Up here, here's essentially credentials of the assembly manual web app, which is where to upload the data, the SVF and the BUF that I've mentioned. The next part of this configuration has configs if you want to use the last active representation, and same for model state, or if you want to have your own and you kind of know the names up front. This part is to configure essentially exported information with every occurrences. So in this case, it's all iProperties from Inventor, but there could be something else like a BOM structure, for instance. And this last part of the configuration is the most interesting one, and I'm going to demo this bit here. Essentially, we have two sections with which we tell that based on a condition, the component should be merged even though it's an assembly or sub-assembly in the context of the bill of material. It should be merged into one single node. So let me show you that real quick. Here I have an assembly open that has a weldment part down here. So it's this rod. So when I click on this rod, it will select the other parts that are Inventor in Inventor as a defined as a subassembly. So it's like a multi-component subassembly. But for our needs of assembly manuals, it is just a single entry in the BOM. And so this configuration kind of makes that happen to kind of stop the processing at the node of the BOM. It's a little bit of a DSL. As you can see, there are some sections called left-hand side, right-hand side, and a comparer method. And here you can kind of define yourself what you want to compare in order for the configuration to apply. So you can have here equals, or as you can see here, contains. For the comparator method, it's essentially methods that are defined on a .NET string. So anything like starts with or ends with or other methods that are on the .NET string type can be used here. Of course, you need to be careful because this is resolved at runtime, so it might crash the process of retrieving of the data from the assembly. So what about the metadata? As you have noticed, I have mentioned the BUF file, but first we set up both of the translators to kind of not export inventor properties, iProperties, and here's the way we do it. Here at the top, it's really the config for the DWF translator, as we don't know how to configure the DWF to SVF exe tool, so we have to do it for the DWF translator. And the strange config here that I mentioned is the include empty properties. Why I think it's strange, essentially, I don't know why, but you have to set it and you have to set it to 0. Otherwise, without that, it doesn't really work. And what we have here is a dictionary because essentially the configuration options for this translator is kind of something that we pass to a library that my colleague has developed. So there is nothing like a name value map and other things like down here in the case of Inventor Translator, where we directly use the Inventor API. Here I highly recommend you to read the blog post from Adam Nagy from Autodesk. He essentially kind of explains, and I think it's the only place on the internet, or at least that I found, where he explains the individual options of the Inventor SVF translator. And I especially like this method called get has save a copy as options, which pre-populates the options name value map object with the defaults, and then you just specify only the options that you need to be set differently. What does it look like in the viewer itself? So the when you select a components, you have this properties dialog. Essentially, there are just two pieces of 2 pieces of data after all the inventor properties are not exported. And this name really means occurrence name, as you can see, is denoted by the column number. And here the component ... means the component or document name without the colon and number. So as for the BUF file, we've decided to use something called protocol buffers. On this slide, you can see on the right-hand side a data represented as JSON, and the same data on the left shown as the protobuf format. As you notice down here, the same name on the end of it's kind of the trimmed output of JSON is already on line 4 of the protobuf output. And this is a kind of a view when you open the binary in VS Code. So it's a little bit of a strange here. And the significant thing that you notice is missing is all of these property names that are here in the JSON. And that's the reason why the protobuf is like a more compact. It can fit in more data, but of course the JSON can be minified, so it can be a huge long one-liner. But as you can see, what's really readable here are only the string pieces, the string parts. The other stuff is really just a binary, so it's not representable as plain text. The downside maybe of the protobuf is that you have to have a protobuf schema in order to kind of tell your program how to decode the data that you're storing. So in this case, for our bill of materials, we have just this simple schema. So as you can notice here that this essentially object for or data type for assembly called assembly info kind of references itself, so it's that way it makes the data structure recursive, and it also with the same keyword here called repeated holds a list of parts. So that's how you kind of with the repeated keyword define or make it represent not only collections like lists, but also a recursive data structure. So it's a rather simple protocol. And the key idea here is that every single property here, property name is kind of replaced with these numbers here. So they're and in the binary, they're encoded really just as numbers, not really as the property names. So what about the file size? If you compare JSON to protobuf, then for the same data, in our case that I'm showing here, the protobuf is twice as small, 80 kilobytes here. One downside of the protobuf is that we essentially had to come up with our own extension for it that we call BUF. And then when we needed to deploy the application to production, we had to use IIS, and there we had to define, as IIS is not aware of the BUF file format, our own MIME type. So this application /x protobuf MIME type is something I think Cloudflare came up with. So that's as per their recommendation is what we use. And as you can see down here, then based on that MIME type, you can tell IIS to enable the compression, and also down here, caching header can be set up. So that's an example of IIS configuration. And what does it look like in the web browser network tab? So that same 80 kilobytes file gets compressed down to about 12 kilobytes. So even though the protobuf format is kind of compact, at least compared to JSON, it's also highly comprimable. Let's talk about some of the assembly manuals related development gotchas and what it is made of. So here is the web tech stack. On the top here, you can see logos of what I think of hopefully will be or is the boring part of the stack that shouldn't change too much, even though lately in .NET there has been things changing a lot. On the bottom here, you can see logos for more of the front end part of the stack. So here's TypeScript, Tailwind, and Webpack. And we use another bundler here called ESBuild. I know ESBuild could be used standalone, but it's not really labeled yet as kind of 1.0, even though all software developers kind of know it and use it. In this case, we use it too, but since Webpack is also a bundler and Webpack is able to Webpack the ESBuild bundle, we kind of use them together in Webpack. And the reason why we use ESBuild is to speed things up, but hopefully someday TypeScript will have the compiler written in Golang in stable version. So as ESBuild is also written in stable version, it might not be necessary since ESBuild isn't really meant to be a TypeScript compiler. It just removes the types. So it's kind of dangerous to use it, even though it's nice that it speeds the build up by a lot. Here on this slide is something called hit test. So it's from the APS Viewer API. And I've been told about this by Varun Patil from Autodesk. And this thing, I couldn't really figure it out for a while, how and why it's useful, but in the end I did. And essentially for the project of assembly manuals, it's a game changer, and I think I'll be using it in other projects, which I'm already doing. And I don't really understand why it's hidden under the Impl namespace. I was kind of hesitant to use it at first, but then I figured I could use it to essentially, as shown here in this function, where you can provide X and Y coordinates or where the user clicked, kind of like I have shown in the demo before, to retrieve essentially through the hit test the DB ID of that component that the user clicked. And then based on that, you can similarly, like I did, change the selection. The next thing that we use from the Inventor API that was also hard to find out, but help was provided with this from Peter Brosh from Autodesk. He kind of knew right off the bat that what this essentially hidden property under an extension, which means there are no TypeScript types for it, and I didn't really find any documentation for it, but he knew about it right away. If we set it to true, then we can kind of get the effect of multi-selection of components. Also includes the selection of components that are like covered behind and not facing the camera, which is often the case with machines and things like that in manufacturing. So this selects kind of all the stuff that the selection box intersects. The other thing we dealt with related to the APS viewer is persistable markup. And so we need markup to kind of, on some steps, annotate some of the parts and kind of make them more significant and maybe describe to show what to do at that particular step. And so we decided to use markup score and markups GUI, which are both extensions of the viewer. And we had to wrap these with our own extension that we call custom markup extension. So there is a little bit of a problem still with this extension. It has the option to draw text, but since that's kind of not working well or not working at all, mostly, we had to decide to put below the viewer a description field where we kind of provide the option to do these circle emojis of the same color as there are colors of these annotations, and next to that and the person that defines the step can provide the description. So that's how we kind of relate text for now. There is a little bit of a problem with the markup score extension during initiation. So I've kind of had to, because sometimes markups extension doesn't really initiate on the load of the page of the viewer fast enough, and the user might already start clicking on it. So I kind of had to do, as you can see here in the code, some sort of a busy loop in where in the loop I permissify set timeout call to see if the markup score extension is available. It looks kind of ugly, but most of the time it makes sure that there is no problem with the markup extension in initiating. It just seems like for the user for the moment, right after the page loads, that it doesn't work, but then it starts working. The other thing we did and we had to do is because not only the bill of materials data, but also the manual data themselves are quite big, quite complex, and quite nested, and we store manuals in the database. So if we have a case of a complicated manual, then we kind of have to wait a bit for the data to come out from the database. And in that case, what we did is to kind of offload the work of waiting for the database query and then parsing the JSON data of the manual to a worker thread. So I'm going to show you this in the code. I have a manual page class here. That's the first thing that's loaded. When the manual is loaded, it has a private constructor here. That's because constructors in TypeScript or JavaScript cannot be marked as async. So it has this initialize method. And here's a thing about service worker. And now the constructor is called. So a new instance of it is created. And here's the potentially block and call. It could take about 8 to 10 seconds on very big manuals for this call to kind of return. So this would be blocking and the user would be waiting and looking at a blank page. And the important thing is to load the viewer and not just wait for the data from the database. So we decided to do the fetch manual call. That is the function that I've shown you on the slide to perform it inside a worker. And so the process can go on while the database query is going on. And here is the important thing that should happen on the main thread that also takes a while. And we have this in a viewer wrapper initialize again, because it's also async. Essentially what this does is it loads the viewer and then also loads the model inside the viewer so that the user can almost immediately see that something is happening. And once the worker is done, in the separate thread, it emits this onMessage event. We can await the viewer wrapper promise that happens in the main thread and kind of join the worker thread to the main thread here as the event object holds the manual data. So this is the fetch manual function again. It's a little bit tricky, a little bit ugly. It doesn't know the base URL, and here's sort of the inline code for the worker, but it makes things look much smoother when the page is loading. Here on this slide, I'm essentially showing you production bundler or production code for the front end JavaScript and TypeScript. And I would just like to mention it that you should split your code and you should make sure that there are these hashes in your files that your bundler is providing. Webpack has something called essentially content hash, and that is to prevent caching in your web browser. If you need to redeploy your application often, that's very helpful. So here is what LOC stands for. And now we are in the end of the presentation, but this section is more about to kind of show you what you can expect to write as an amount of code if you decide to do something like we did. So here are some stats for the Inventor library. It has 2,700 lines of code. The Vault extension has a little less than 2,000 lines of code. Both of them are mostly in C#. And the assembly manuals is the largest piece, the largest software component. It has over 18,000 lines of code. And most of that, and some say, expect to be writing like 70% of your code around the viewer if you decide to use the viewer. So the TypeScript really is the front part, even though there is a lot of backend code in C#. What are the takeaways from this talk? I'm just gonna mention quickly two here. So kind of think about the principle of locality. Make sure that the compute and the data is as close to your user as possible. And for offline experience, make sure to implement the service worker so that the assets of the Autodesk Viewer can kind of be cached in end user's web browser. That's it for me. Hope you got anything useful from the presentation. Goodbye.